Black holes have been a scientific mystery for decades. It's really hard to learn about things that are far, far away and you can't even see them. But we intend on teaching you guys what black holes are, and we're going to go over the types of black holes, how they formed, what they do, like inside of black holes, and end with some questions that we're not really sure about yet. So I'm going to talk about the types of black holes. There are about three types, like three major types, and they are the stellar black holes, miniature black holes, and supermassive black holes. Now, maybe you guys already have like an idea of what a black hole is, like some sort of crazy, violent lightning storm in space on a sci-fi movie. And that's not necessarily true. They're actually invisible. The stellar black holes are what you consider normal black holes. They're actually very, very heavy. In order to be called a stellar black hole, the mass of it has to be a 1 with 31 zeros afterwards, which is actually about 3 times the size of our sun. And this is actually according to Ted Bunn from the University of Berkeley, or California in Berkeley. Now next we have miniature black holes. They are actually probably the hardest to talk about because we actually haven't observed any. It's all just a theory here. But these are interesting because theoretically we could make them. Like, I don't know if you guys remember the stuff a couple years ago about the Large Hadron Collider in Europe, the CERN. And they were all worried, oh, we're going to make a black hole inside. And actually, it kind of is a little possible, but they're so small, we don't know a whole lot about them. It wouldn't be an issue. But that's miniature black holes. Now, the supermassive black holes they're supermassive. Yeah, that's really the only special thing about them. They're just pretty big stellar black holes. But once they're that big, there is special characteristics about them. It is believed now, actually, that there is one stellar or one supermassive black hole in the center of every galaxy, and they kind of act like an anchor for the galaxy. But those are the types, and now how they're formed.
The method of gravitational collapse is pretty fascinating and easy to understand. A star burns away, and there's a nuclear reaction inside the star that burns the fuel inside the star. And after a while, the star starts running out of fuel, and it empties out the star's center. And as it hollows out, the outside layers of the star start filling in the center. But not all collapsing stars become black holes. The deciding factor is the star's mass. The star has to be 3 times the mass of our sun to become a black hole. So as the star starts collapsing, the hollow shell rushes into the center and triggers an explosion. And if a star is 3 times as big as our sun, it develops into a black hole.
Well, while that star is collapsing, what's happening around it is a event horizon is coming out of the middle, and once it gets to a certain point, it just balloons out. And what the event horizon is, which is what you don't want to get into with black holes. It acts as a skin or a surface of the entire black hole, and it has its own gravitational pull also. And inside the event horizon is what we call an apparent horizon, which is what's gonna really mess you up. And if you were traveling in space and you were to get close enough to the event horizon, it sucks you in. And once you're in there, you can't get out. And it's just the bars, pretty much, of the whole black hole. Because, I mean, you're just floating through space and time when you're in there, and you can't get out. But once you reach the apparent horizon, everything starts to go wrong. That's what sucks everything in and distorts time and space. Beyond the event horizon, there's nothing. So it has its own dense gravitational pull. And after you get past the apparent horizon, there's a singularity at the very center of the black hole. We call it the singularity. And it's where matter is just crushed up and messed up and all that. And it's just incredibly dense. It's so dense. It has a regular black hole has as much dense equal to 10 suns, or the radius of 10 suns. After it's all collapsed. And once you reach the event horizon, it separates light rays, and they're just trapped in there forever, and they can't move away from it. Yeah, so once you're in there, you're screwed.
I'm going to talk about the timing and how it's different after you reach the event horizon. If people were to be able to go through a black hole and survive, the timing is extremely different. If I and someone else was wearing a watch that was set at the exact same time, and I were to fall into a black hole and pass the event horizon, the timing would be so different that if I were to be able to see somebody live, I would be able to watch them live their whole life and have their kids grow up and then pass away. And that would be to a minute to me. That's how different the timing is. But timing in space disappears after the apparent horizon. It's like it's like a cell where it just everything goes away. But obviously no one can go through a black hole and live, because nothing can really escape it and live past it. If we were to live through a black hole and the timing was so different, if it wasn't for everything crushing you, you would be able to live for years and years and years in it, because of the time difference would be a minute to probably 1,000 years on the life on Earth.
With all the theories in black holes, there's still a lot of speculations because we have no real evidence of black holes. No one has a personal testimony on experiencing a black hole, and that makes for a hard time to believe they really are, because most people go off seeing is believing. And another part is that black holes were founded off of general relativity, which renormalizing is a hidden, and well, it's hidden with an idea of field strength, which covers their lack of precision, which so makes it unnoticed. But the lack of complete field strength is caused by trying to force equations to contain entities that cannot logically be contained, such as the zero-dimensional point, which is the center of the black hole. It can't be contained in any cardinal or counting number, so the only way they can accurately measure a black hole is through general relativity, which isn't real numbers. This mistake infected calculus from the beginning, and it still infects all contemporary math and science, since all higher math is founded on differential equations. In conclusion, we have taught you about formation, the types, the types, the event horizon, the time differential, and the speculations of all views on black holes. Thank you for listening.
Can I have one thing else?